Today we're going to be looking at the equations of tangents in Chapter 3 in Exercise 3a. More specifically, we're going to be looking at question 10a and 10b. Starting off with 10a, find the equation of the tangent to y equals ex at the point where x equals a. Before completing any specific calculations, it's important to acknowledge the 4 general steps to finding a tangent formula. Number 1, find your x and y value at a specific point. Number 2, find your slope. This is your general derivative. Number 3, find the slope at a specific point. For instance, when x equals a, you would substitute a into all x points in your derivative. This would find your derivative at the point when x equals a. Number 4, sub these values into the tangent formula. Now let's look closer at the tangent formula and the 3 components that are a part of it. The tangent formula reads as y equals f of a, x take a, add fa. The f of a is the derivative at a specific point, as mentioned in part 3 of finding the tangent formula. The x take a component is where you would sub in your x value. And the f of a is basically your y value when a is subbed into the formula. Now let's take a look back at our question and use all these points to find the tangent formula. When x equals a, it was found that y equals ea. This was found through substituting x for a in the original formula. This means that the point of contact is AEA. This means that step 1 is complete. Now it's time to find the derivative. As we are aware by previous rules, it states that when the function is ex, the derivative is also ex. In this equation, we are using ex, hence our derivative is also e to the power of x. Now that we have found the general derivative, hence completed step 2, we must find the slope at the point, hence substitute our x value into the derivative. It's found that when x equals a, the derivative equals e to the power of a. This was found through substitution. To find the equation of the tangent, we substitute all values back into the equation, and we end up with y equals e to the a, bracket x take a, bracket add e to the power of a. We then expand this equation and factorise to result in our ending formula being y equals e to the power of ax, add e to the a, bracket 1 take a. Now we will move on to part B, which asks, find the equation of the tangent for y equals ex, which passes through the origin. Although this is the only information we're provided, we can assume that the origin Although we are provided no more information than this in the original question, we can imply that the origin means the coordinates have 0, 0, meaning x and y will both need to be 0. By substituting x and y into our final tangent equation, you will end up with the equation 0 equals e to the power of a times 0 add e to the power of a, bracket 1 take a, bracket. The starting component of the formula, because it's multiplied by 0, will result in 0, meaning that the formula we're now left with is 0 equals e to the power of a, bracket 1 take a. We then want to get a by itself in order to find its value, so we're dividing both sides by e to the power of a in order to get rid of that e to the power of a out the front of the equation. 0 divided by e to the power of a just results in 0, and the right hand side will just equal 1 take a. And then to get a on its own, you want to add it to the other side, resulting in a equals 1. And then going back to our original equation of y equals e to the power of ax, add e to the power of a, bracket 1 take a. Using our now known a value, which is 1, we substitute this 1 back into the equation, which gives us our y value of y equals ex. We then want to substitute our final a value that we found in part B into the equation found in part A to result in the equation y equals e to the power of 1x, add e to the power of 1, bracket 1 take 1, meaning that our final tangent formula is y equals ex. So the answer to Find the equation of the tangent to y equals ex, which passes through the origin. Is the tangent to y equals ex, which passes through the origin at the coordinates 0, 0, is y equals ex, as we found through substitution.